All right, this video is a continuation of the hypothesis testing video where we learned how to set up your null and your alternative hypotheses. We're now going to take the examples from that hypothesis setup and go with those in order to actually do a full hypothesis test. So the first step of a hypothesis test is to set up those null and alternative hypotheses based upon the claim. Now, the next thing to do is to see, based upon the sample information that we have, if the claim can be upheld or not. And in order to do that, what we're going to do is we're going to standardize our sample information by creating a z-score or a t-score for means or a z-score for proportions. And we're going to hold up that standardized score to the population. So we're going to find the probability of that underneath the population and to see if it is unusual. Now, quote, unquote, unusual is what we're looking for. Now, that unusual is going to be determined based upon what we call the rejection region. And that rejection region is going to be based upon our alpha or our alpha over 2. Now, if it's a one's-tail test, then it's going to be just based upon alpha. And if it's a two-tail test, then it will either be based upon alpha over 2 or we'll do 2 times the probability and then compare the 2 times the probability back to alpha. And that's typically how it's done because that's how technology does it these days. So now let's go look at these examples. You've kind of got an idea of what it is that I'm going to be doing. I'm going to be calculating a z-score or a t-score for means or proportions, so means or proportions, and I'm going to do that, and then I'm going to find the probability to see if it's unusual in comparison to where the rejection region is, which that rejection region is set up based upon alpha or alpha over 2. So let's take a look at our first example, the proportion example. So remember that a manufacturer of new medication is testing it against an old medication that had a success rate of 60%. The manufacturer will not accept the new medication unless the success rate is better than the old. So that was where we got our hypotheses. So now reading further, it says they want to test that it's a 99% confidence level. So, well, 99% is going to go over here. So if 99% is the case, then it's just like everything else. This, the complement of 99%, the alpha, is going to be the rejection. And all that alpha is going to go into this tail over here to represent our rejection region. So this is what we're going to use in order to make our decision. So we're now going to compute a test statistic for this. Now, as long as our x's are greater than 5 and our n minus x's are greater than 5, then we can use the central limit theorem and nothing is amiss. So let's go, oops, that's not the way you spell that. Let's go over and take a look at the values. So our sample information that shows that we have 1,200 trials and 750 patients that were successful. So that means our x's are going to be 750 and our n minus x's is going to be 1,200 minus 750, and that is going to definitely be larger than 5 as well. So we're good to go on that. So our test statistic is going to be a z because p hats are distributed normally, and we're going to take our p hat, which is 750, right? P hat is 750 divided by 1,200. So 750 divided by 1,200, and that's going to go in there. So let me do that division, and I get 62.5%. So I'm going to use 0.6 0.25, because we should use these as decimals, and minus the mean that's under the the null hypothesis, the 0.6, and then divided by, now different than a confidence interval, I want to show you, different than a confidence interval, right? This is the null hypothesis and the alternative hypothesis. This, by the way, is your flow chart from Beoga. You'll find it under the flow charts and tables, and it's the one sample tests. And here it's the null. And remember, in a confidence interval, you would see here a p hat and a q hat, but that's not the case. So just keep that in mind. And then we have 0.6 here, and the complement of 0.6, 1 minus 0.6 is 0.4, that's Q naught. And then we're going to divide that by our sample size, which is 1200. So I'm going to go ahead and I'm going to calculate the denominator and then multiply the reciprocal of that, or divide 0.625 minus 0.6 by that number. So I like to compute the denominator first because it's much more complicated than the numerator, and it just saves me some time. And I get a test statistic value here of 1.767, actually 7.8 if I'm around there, which, remember, we take these to 2 decimals, so 177 is approximately my value. So now what I want to do is I want to find out, is this unusual or not? So I want to find the probability of that. And my unusual gauge is going to be if it's less than that alpha value. So this is less than 0.01. That's what I'm asking. So less than 0.01 is going to tell me that it is. So my probability says the probability that a z is greater than, and that's how I'm going to do this, is greater than, because my alternative hypothesis is, right? So my test statistic is somewhere in this distribution, and I want to know if it's in this tail or not. Is it weird? So that tail is in the upper, so that's the probability that I need to find. So 1.77. So to do this on my calculator, I have to do normal, and then I do my CDF, and then I'm going to do 1.77, and then I'm going to do comma 9, and then end it. And that's going to give me my probability. So doing that, second function, variables, normal CDF, and 1.77, comma 9, and then enter, and this gives me a probability of 0.04. And my question is that less than 0.01? And is it? Is 4/10 less than 1/10? No, it's not. And so what this means is that I'm going to fail to reject the null hypothesis. Now, not only do we have a decision like this, fail to reject the null, but we also have a conclusion that gets brought together as well. And the conclusion is going to tell me 3 things, in my opinion. And those 3 things are going to be, number 1, what is the level of confidence that it was tested at? Number 2, what was the decision that was made, but not using this formal language here, fail to reject? And number 3, what was the original claim in the first place? So if I were to write the conclusion here, I would say at the 90% confidence level, oops, excuse me, not 90%, it was 99%, my bad. Don't want to confuse you, but I'm sorry, I wrote the wrong thing. 99% confidence level, and I'm just going to abbreviate that as CL. There is, and because I failed to reject, there is not enough evidence. So it's not supporting my claim, right? So there is not enough evidence to support the claim that the new medicine is better than the old. Now, I kind of got sloppy on that because it's really hard to write sideways like that on my tablet. So that is exactly what the conclusion would be. Now, I have a difference between what I call the decision, that's a very formal thing, and what I call a conclusion, which kind of says it all. And that's what you'd want to tell a client, is the conclusion, because it says all the pertinent pieces of information. Now I'm going to go ahead and stop this video, and I'm going to go on for a second video to do problems number 2 and number 3.